Today we're working on present value, and here's the first problem, and we'll go through it and we'll identify certain parts. Now, Steve wants to have $4,000 in 2 years for college expenses. Anything that we want to have in the future, we're going to call the future value, or the amount, just like yesterday. Now, because it says it's in 2 years, that's why this problem is considered a future value. He can invest in a GIC at 3.8%. This is the rate. Now, we're going to change that immediately to 3.8%, which is 0.038. And what I'm going to do is I'm going to quickly show you where that comes from. You take 3.8%, and what you do is you're going to change that to 3.8 out of 100. Punch that in your calculator and you get 0.038. And that is the reason why 3.8% is 0.038. Now, if you can't remember how to do that, just do this calculation on the right side in order to understand that. Now, how much does he need to invest today? So, we already identified our future value. Our future value was 4,000. Now, I'm going to differ from the lesson a little bit, and I'm going to add some variables. We're also going to have a PV. We have an I, and we have an N. Now, we don't know what our present value is, so we're going to calculate that. We do know what I is. It's exactly what we were doing yesterday when we were calculating the rate. We basically would just come up with 0.038, and then we would notice, that this assignment is monthly, compounded monthly. So what we're going to do is we're going to divide 0.38 by 12. And then for our next portion, our N value, the reason why I have these kind of right beside each other is that the I is always divided by 12. And it says this problem is occurring in 2 years. So we're going to start by writing 2, and we're going to times it by 12. Now, our present value is very similar to our future value problem from before. The only difference is a negative n in the exponent portion of the problem. So we'll just write PV is equal to FV times 1 plus I to the negative n. That is the basic equation that we'll be using for this course. Now let's continue. Upon substitution, we don't know what PV is, so we're just going to leave our value there. We're going to leave our variable there. And then what we're going to do is we're going to go and substitute all the information that we have here, here, and here. And so that means we have 4,000 times 1 plus 0.038 divided by 12. That's what our I value was. And then we raise that to negative, well, what's negative 2 times 12? That gives us 24. So 24 months have passed, essentially. So remember, just like before, the I value is just the adjusted rate depending on the amount of the type of compounding. Monthly is 12, so that's why we have 0.038 divided by 12. And N is negative 24, and we have negative 24 here because of N being 2 times 12, because it happens 24 months. So just remember, I'm just going to put this down here. notice, so this is just, so that bracket there is 2 times 12. And I want you to also notice we divide the rate so basically for the I, we're just converting it to the rate that we have monthly. That's why we divide by 12. Every percentage that we get in these problems is a yearly rate, and we have to convert it into yearly, monthly, bi-yearly, semi-annually, stuff like that. Now, once we punch this into our calculator, we follow exactly the same steps we did last day. Remember, this fraction really is 0.038 divided by 12, n bracket raised to the negative 24. And we get the following. Our present value is 3,707.71. So, therefore, if we answer the question directly, we would say it asks us how much does he need to invest today. Therefore, you could write down he needs to invest $3,707.71 today. You could also just write for this problem, the present value is the number. You could have said that as well. Now, you'll notice on your sheet, the present value can be written like this. The future value divided by the bracketed version of 1 plus I raised to the n. Or we could write the present value is equal to the future value times 1 plus I to the negative n. Now, the reason why I call this negative n is because essentially, imagine if I have a future value, we are looking at something that's happening in the future. This is telling us that we're taking the information from the future and move backwards into the past. You can look at it that way. So if you think about this, this is kind of like a time machine. It takes our future value and brings it back to what the original amount was. Now, what you need to realize is that these two equations are identical because of the exponent rules that we learned about a long time ago. This equation here is just the appropriate rearrangement of this equation. So remember, anytime we had something raised to the negative n, in order to make it positive, all we did was just move it down. They are both the same problem. Now, please understand that I intend to make you do a quiz on this, just like before. Now you need to remember, the quiz will still have definitions. 2. On this test, you are actually going to create your own problem this time. You're going to create your own present value word problem. And then 3, you will solve that word problem. Now, you need to actually take the time and practice for this. We can't waste our time in this course. Let's move on to our next page. For this next problem, it says, find the present value of $3,600 in 3 years, invested at 6.125% compounded quarterly. 6.25% can be written as the following. 0.0625. So think of a quarter as 0.25 of a percent. So this is 0.625%. 0.0625 as a decimal. And so now I'm just going to write down like before my future value. Well, I know that it's 3,600. I know that my present value, I don't know what that is. So that's what I'm going to calculate. So I'll start by writing PV is equal to FV1 plus I to the n. So now, if you wanted to, we could write, we'll substitute directly in, 3,600, 1 plus, 0.0625. And now we have to divide by something. And what we're going to do is we're going to take a look at this part where it says it's compounded quarterly. Something that's compounded quarterly, what we have to do is we have to take our rate and we divide it by 4. And then we raise it to the negative. Oh, we forgot our negative sign here. Raised to the negative of, 3. Before we did 3, we did the rate divided by 4, so now it's 3 times 4. 3 times 4 gives us 12. Now, if you wanted to, you could write I is equal to, 0.0625 divided by 4, and then you could write n is equal to, 3 times 4. And that will always kind of get you what you're looking for. And you could do something like this for every problem. Do that first to set you up, and then substitute directly into your equation if you're forgetting. Remember, it's FV, PV, I, and N. And then what we're going to do is we just punch that into our calculator. By punching it into the calculator, we get PV is equal to $2,988.33. Therefore, the present value is $2,988.33. And we're done. Now, you could technically, if you wanted to, use this format here by setting up FV, PV, I, and N. And every time you do your either future value or present value, you could write out all of the variables at one time. It's up to you. Now, I don't tend to. I tend to skip the I and the N's, but you guys, maybe that would make your life easier. Now, because I'm not teaching it, I never got around to be able to add that to the note. So now, what I want you to do, let's figure out what our interest is based on this. Now, just like before, we said the interest for anything was equal to the amount that we have at the end, which is the future value, and when we subtract it from the start, which is our present value. So we end up with $3,600 minus $2,988.33, and that gives us our final answer of $611.17. Therefore, the interest earned is $611.17. Now, based on all these calculations, these are the problems that I'm asking you to do. They're not that difficult. They're just a little taxing. And it's 13 to 15 as well. So it's page 82, number 7, number 6, 7AB, 11, 12, 13, and 15. These are the types of problems that I want you to do for today. Good luck, guys. Notes are online, and your teacher will give you a copy of the questions for the day. I'll also upload a small version and a large version of the problem set on the internet. There'll also be solutions for each one.